जय जगन्नाथ महातारी नम पिलाने आज आपण मानक एक एलिमेंटर पार्ट 2 बोरन विषय कहबी। तेणुक यह विभिन्न प्रकार परीक्षा पड़े बा ऑल एंट्रांस एग्जामिनेशन रे यही बोरन विषय आसी थाए। तेणु आपण माने भल भाव टिके शुणिले बोरन विषय जानीपारे बा थियोरी ऑफ बोरन Part 2. The boron 10 isotope is unique is that it possesses an extremely large capture cross section for thermal neutrons. That is, it readily absorbs neutrons of low energy. The capture of a neutron by a nucleus of this isotope results in the expulsion of an alpha particle nucleus of a helium atom symbolized 10 boron plus neutron 1 is 10 to lithium 9 plus alpha 4. Since the high energy alpha particle does not travel far in normal matter, boron and some of its compounds have been used in the fabrication of neutron shields. Materials not penetrable by neutrons in the geysers counter alpha particles trigger a response, whereas neutrons do not. Hence, if the gas chamber of a geyser counter is filled with a gaseous boron derivative, that is boron trifluoride, the counter will record each alpha particle produced when a neutron that passes into the chamber is captured by a boron 10 nucleus. In this way, the geyser counter is converted into a device for detecting neutrons, which normally do not affect it. The affinity of boron 10 for neutrons also forms the basis of a technique known as boron neutrons capture therapy or BNCT for treating patients suffering from brain tumors. For a short time after certain boron compounds are injected into a patient with a brain tumor, the compounds collect preferentially in the tumor. Irradiation of the tumor area with thermal neutrons, which cause relatively little general injury. Compounds. In its compounds, boron shows an oxidation state of +3. The first three ionization energies of boron, however, are much too high to allow formation of compounds containing the B3 plus ion. Thus, in all its compound, boron is covalently bonded, that is, one of boron's 2s electrons is promoted to a 2p orbitals, giving the outer electron configuration 2s1 2p square. The s and p orbitals can then be mixed to give sp square and sp3 hybrids, which allow boron to be 3 and 4 coordinated respectively. The 3 coordinated derivatives, that is halides, alkyls, aryls, are planar molecules that readily from donor acceptor complexes called adducts, with compounds containing a lone pair of electrons in these adducts. The boron atom is 4 coordinated, the 4 grooves being tetrahedrally disposed around it. The tetrahedral bonds result from the reception of an unshared pair of electrons from a donor atom, either a neutral molecule or an anion. This allows a variety of structures to form solidly borated. So 5 types of structures involving several anions, that is BO3, 3 minus, formed of boron and oxygen and shared electron bonds. The most familiar borate is sodium tetraborate, commonly known as borax, Na2B4O7, NaOH2O, which occurs naturally in salt beds. Borax has long been used in soaps and mild antiseptics, delivering an electric charge. Discharges diboron tetrachloride Cl2B, BCl2 and tetraboron tetrachloride B4Cl4 are formed. Diboron tetrachloride decomposes at room temperature to give a series of monochlorides having the general formula BCl4N, in which N may be 8, 9, 10 or 11. The compounds with formulas B8Cl8 and B9Cl9 are known to contain closed cages of boron atoms. Boron also forms a series of halides with the general formula BnXN, which also contains closed cages of boron atoms. One example is boron chloride B4Cl4. Unfortunately, these interesting halides, most of which are highly colored in sharp contrast to the more typical boron derives, are exceedingly difficult to prepare and to handle. The substance B4Cl4, for example, can be prepared only in milligram quantities, and complex electrical discharge techniques are needed for its production. Furthermore, it ignites spontaneously in air and is rapidly decomposed both by water and even by the grease used to lubricate the vacuum equipment employed in its preparation. With hydrogen, boron forms a series of compounds called boranes, the simplest being diboron B2S6. The molecular structure and chemical behavior of these boron hydrates are unique among inorganic compounds. Typically, their molecular structure reveals some boron and hydrogen atoms closely surrounded by or bonded to more atoms than can be explained by an electron pair bond for each pair of atoms. This variance led to the concept of a chemical bond consisting of an electron pair not localized between two atoms but shared by three atoms, 3 centers, 2 electrons bond. The unusually 3 entered 2 electron bonds led to a variety of polyhedral boron hydride compounds. The most common and well-known boron hydrates include the decaborate B10H10 minus and decaborate B12H12 whole 2 minus anions. When the boron hydride clusters include carbon atoms, they form carbonates or carbonates according to International Union of Pure and Applied Chemistry nomenclature. The most commonly encountered carborane cluster is ixohedral dicarborane C2B10H12 depending on the location of the carbon atoms in the boron cage. Dicarbonates are classified into three isomers: ortho, carborane 1, 2, C2B10H12, carborane 17C2B10H12 and para-carborane 1,12C2B10H12. Polyhedral boranes and carboranes have application in fields such as hydrogen storage and medicine, and they also act building blocks for dendritic macromolecular structures. Diborane combines with a wide variety of compounds to form large number of boron derivatives. Because of its ability to dissolve metallic oxides, it has also found wide applications as a soldering flux. Another boron compound with the diverse industrial application is the boric acid H3BO3. The white solid, also called boracic or orthoboric acid, is obtained by treating a concentrated solution of borax with sulfuric or hydrochloric acid. Boric acid is commonly used as a mild antiseptic of burns and surface wounds and is a major ingredient in eye lotions. Among its other important applications are it used as a fire retardant in fabrics, in a solution for electroplating nickel, or for tanning leather, and as a major constituent in catalyst for numerous organic chemical reactions. Upon heating, boric acid loses water and forms metaboric acid HbO2. Further loss of water for metaboric acid result in the formation of boron oxide B2O3. The latter is mixed with a silica to make heat resistant glass. Borosilicate glass for use in cooking ware and certain types of laboratory equipment. Boron combines with carbon to form boron carbide B4C, an extremely hard substance that is used as an abrasive and as a reinforcing agent in composite material. Boron combines with various metals to form a class of compounds called borides. The borides are usually harder, chemically less reactive, and electrically less resistive, and have a higher melting point than the corresponding pure metallic elements. Some of the borides are among the hardest and most heat resistance of all known substance. Aluminum boride Al-B12, for example, used in many cases as a substitute for diamond dust for grading and polishing. With nitrogen boron forms boron nitride Bn, which like carbon can exit into alumbrific, chemically identical but physically different. Forms one of them has layer structure resembling that of graphite, whereas the other has a cubic crystalline structure similar to that a diamond. The latter allotrophic from called borazone is capable of withstanding oxidation at much higher temperature and is extremely hard. Properties that make it useful as a high temperature abrasive. Boron reacts with all halogen elements to give monomeric highly reactive trihalides BH3, whereas X is a halogen atom FClBr or iodine. These so-called Lewis acids readily complex formation between boron, trichloride and trimethamine, as well as between boron, trifluoride and fluoride ion are shown in the following equation. BCl3 plus NCH3 whole 3 which tends to CH3 whole 3 N BCl3 or BF3 of F minus is tends to B4 BF4 minus, in which the heavy do indicates that the bonds is formed between the nitrogen and boron atom. When boron trichloride is passed at low pressure through devices. पिलामाने ए वीडियोटी जदि आपण मानकु भलो लागुताय लाइक करंतु शेयर करंतु सब्सक्राइब करंतु। रोज नमस्कार।